My plan today is to just get ready for the test. The last 10 minutes or so, I'm going to go over to the Canvas site and show you what is there, most of which you've seen before, but there are some other things. One particular thing that's new that I'd like to show you. So I'm going to start off with these 5 topics, and after that, anybody else has got some things they want me to go over, or ask questions, whatever, we can do that. I'm picking these because I've had homework questions, emails about these general events, and so let's get them done. I've got my little notes written down, but I'm going to do them again. Right, start with the first one. They talk about what are called mutually exclusive events. You'll also see the word in other textbooks, disjoint. It's the same thing. Right. I want you to imagine that event A is all this stuff, and event B is all this stuff. Then that is an example of 2 mutually exclusive events. What that says is that if you belong to this one, you cannot belong to that one, and vice versa. So an example may be, say, from cards. A is clubs, and B is diamonds. So those 2 are mutually exclusive. Would you agree if you're a club, you can't be a diamond, and if you're a diamond, you can't be a club, right? Separated out, mutually exclusive. Now, you can do a quick test for that. That mathematically, the probability that A happens, given that B has happened, will be 0. So if you come up with a probability, a conditional probability, where the probability of A given B is 0, then you know that A and B, whatever those 2 things are mutually exclusive, right? You can't be one without the other. Some examples, I wrote down some. There's hearts and clubs. Suppose A is people who are over 6 feet tall. And suppose B is people who are shorter than 5 feet. Would you agree those are mutually exclusive? You don't get too many questions involving it, but from what I recollect, the question that I was asked was one of those questions where they gave you 2 events and then they gave you like 5, it's like a multiple choice, and you picked the one that was correct, and you would say that they are mutually exclusive because if you're in one, you can't be in the other. And so that was just a term. Mutually exclusive. Right, connected to that guy, there is what are called complementary events. So 2 events, A and B, are complementary if they are mutually exclusive and their probabilities add up to 1. And when that's the case, instead of calling the event, say, A and the other one B, you'll find that, well, I'm not sure what they do. I think they call them A and A with a little C on it. Right. So if you see an event called A with a little C in it, it's a complementary of A. So, for instance, A could be the hearts and the diamonds, which is just another way of saying the red cards. Then the complement of that would be the spades and the clubs. In other words, the black cards. So two events are two events are complementary events if they are mutually exclusive and their probabilities add up to 1. And it's very often they're just those A, B, C, D multiple choice. So here are two situations. One, the two events are complementary, and the other they're not. So in the first example, A is going to be clubs, and B is going to be hearts. In the second situation, A is going to be face cards, and B is going to be not face cards. These two, even the way I've written them, it's kind of obvious that these are complementary. Would you agree? You're either face cards or you're not. Right? If you add them up, you get 1. But you might not realize that these are not complementary. They are mutually exclusive, right? If you're a club, you can't be a heart. If you're a heart, you can't be a club. They're mutually exclusive. The reason they're not complementary, the probability you get clubs plus the probability that you get a heart. Well, getting clubs is 13 out of 52. Getting hearts is 13 out of 52. Do you see that doesn't add up to 1? If you did face cards, there are Jack, Queen, King in all the suits. So face cards would get you, if you count this as the face cards now, you would get out of 52, you would get 12. And not face cards, there would be 40 of those. And you see in this case, it does add up to 1. So if you're given two events and you know that they're mutually exclusive, but you're not sure, are they complementary or not? You would do that. So can you imagine that you might get 4 choices? They are complementary and mutually exclusive. They are not complementary and mutually exclusive. And then I guess the other two combinations would be they're complementary but not mutually exclusive. That can never happen in some other sentence. It doesn't make sense. So are we comfortable with just the terms? There's two events. Some are called mutually exclusive because they don't share anything in common. And a specialized subgroup of them are called complementary because not only are they mutually exclusive, when you add them up, you get everybody. You get a probability of 1. Here's the next one. This is going to be independent. Two events are independent when the outcome of one has no effect on the outcome of the other. So two events are described as being independent when the outcome of one has no effect on the outcome of the other. So you could have, for instance, event A is getting a king, and event B is that it's red. Now these are independent events. In other words, if I told you that this happened, it has no effect on the probability of that. If I told you this had happened, it's no problem on that. So what does that look like as a test? The probability of A is the same thing as the probability of A given that B has happened. So if this is true, if the probability of A on its own is the same number as the probability of A given that B has happened, then you are looking at two independent events. So let's do a check on this one. The probability that you get a king is 4 out of 52, which is 1/13. What's the probability that you get a king given that it was a red card? Right, since you know it's a red card, that means it was 26 cards that could have happened, right? The 13 hearts or the 13 diamonds. Out of those 26 cards, how many of those 26 are kings? 2. And doesn't that, although it starts off with the same number, do you see that these are equal? What that kind of tells me is knowing the color of a card doesn't give me any information that is useful about whether it's a king or not. Now, if I switch places with them, wouldn't the probability of getting a red card, given that it was a king, wouldn't help, right? It would, they'd still be equal, right? So that's what independent events look like. The outcome of one has no effect on the other. Some events are dependent. They do affect each other. And when they are dependent, then we have to be very, very careful about calculating the probabilities. We've got an and or as they are used in probability. So let's look at two events, A and B. So if I asked you, what's the probability that you get a king and it's red? In probability language, you're asking for red kings. You're basically saying the probability of both things. So what's the probability that you get a king and it's red? Well, there are 52 cards in a deck, but there are only 2 red kings. So it's 1 out of 26. Okay, so that's what and can very often look like, that you have to look at both things happening. Now, if I do A or B, that's a little bit different. That, in probability language, the or means anything that's in A and or anything that's in B. That's a little bit different from English. If you've got a kid and you say to them, you can have ice cream or cake. In the English version of or, doesn't that typically mean you can only have one, but you can't have both? Right? You can have ice cream, that's fine. You can have some cake, that's fine, but you're not allowed to have ice cream and cake, right? That's the English or. The math or, the statistics or, is a different kind of or. It's an inclusive or, if you want the jargon for it. So imagine I went and did, what's the probability that you get a king or a red card? Now you got to be careful how you count these guys. And we've done ones like it before, but evidently some of you are still having issues with the counting process. The thing you have to be careful about is double dipping. And what I mean by that is counting the same thing twice. Now, if I did just count the kings, there's 4 of them. And if I counted all the red cards just on their own, right, with no reference to anything else, there's 26 of those, isn't there? And if I thought the answer was 30 out of 52, I would be wrong in this particular question, wouldn't I? Because haven't I already counted some of those kings already? And how many of those are the double dippers, the ones I've counted twice. Agreed? 2. The king, the 2 red kings. So if you want to do calculations with an or in it, yeah, you can put down how many are in the first group. You can add it to how many in the second group. But then you have to say, is there anybody who's in both? Right? The ands, if you prefer to use that. And if there is anybody in both, will you remember to subtract them so you're not double dipping? And if you do it that way, you get 28 out of 52. I believe you get 20 out of 52, which if you do a, what can you do that one? Well, you can do a 7/13. Okay. Are you comfortable about and or and how they're used in probability? And is really both things happening, and or is one and or the other, right? And when you do the ors, look out for double dipping. And the last one I want to do is just a little bit more on conditional probabilities. And it came up with a question that someone asked. I'll put in my own version of it. I can't quite remember the details. But basically, there are 40 people in the class. And the teacher's going to choose 3 people. To ask a question. And I think they describe the event as C1, C2, and C3. So C1 is who she picked for question 1, right? And C2 is who she picked for question 2, and C3 who she's going to pick for question 3. Now, the way the question is described, these 3 people are kind of picked out of the class, and if it helps, can you imagine she dragged them out to the front and had them face the class? Is a totally scary thing that your high school student probably did to you a couple of times in your life and has still had a traumatic effect on you, right? People of that age do not like to be picked up and put in the front of the class and stare at everybody. Adults sometimes do like it. So that's the basic storyline. And then they talk about 2 different kinds of probabilities. And the first one is, what would be the probability that this one particular person, pretend it's you, what's the probability that you get chose for question 1? Well, there's 1 out of 40 people. So that's your probability. What's it totally independent? What's your chance that you get chosen to do question 2? It's still 1 out of 40. And suppose it was question 3, it's still 1 out of 40. Now, suppose I said to you, what's the probability that you get chose for question 3, given that you'd already been picked to answer question 1? Now, this is a trick. In a lot of ways, this is a trick question. What's the probability that you were picked to do question 3, given that you've already done question 1, right? You've already been chosen for it. Any ideas? There's nothing to this question. That's a clue. Last chance?
Is it
1 out of
0?
40.
It is 0. If you've already been picked for question 1, haven't you done your bit and you're going, flipping heck, I'm glad that's over. She can't pick you for question 3. These represent, in the story, you've got to remember, these represent 3 people, right? John, come out, you're doing question 1. Mary, come out, you're going to do question 2. Janice, come out, you're doing question 3, right? And you're John, right? So you've been picked. You're not going to be picked again, right? You can only be chosen once in this storyline. So not all conditional probabilities, sometimes you just have to think them through. They're not like card games in many ways, and you have to think a little bit differently. Okay, that is all the topics based on people's homework questions that I've been asked to look into. So has anybody got some questions for me? Anything you want to go over? Once we've covered that, we'll then go and look at Canvas and we'll tell you what's going on there. You know, if you don't ask a question, I'm going to tell a joke. So look, that's a threat. Come on, that should get you moving. I mean, if you don't have one, you don't have one. I guess that's also true. Okay.
I actually did have a question.
Ah, good. Go, David.
Yeah, question 17 on chapter 7, Introduction to Probability Homework. I was actually having.
Okay, let me go and find that one.
Okay.
Yeah, 17. I'm going to find it, hopefully quickly. 17.
It's Jill and Zoe.
Intro to prob. Right, I'm almost there. 17. Jill and Zoe. I'm going to put it on the screen. You can then talk about what the heck's going on here. Oh, well, I got the answers there, but that's fine. We can explain why they are the answers. I wish I wouldn't do that. It's definitely distracting. But it's just the way my things load up. Okay. Let's see what the story says. Jill and Zoe have lunch together. They flip a coin to decide who pays for lunch. Is it that one?
Well, yeah. So now that I'm seeing it, I guess it was just how I was entering. This is the frustrating part with how you enter the actual JJ, JL, LJ.
You said just JJ.
Well, I put those ins with commas, and then I guess I didn't have it capitalized. I don't know. So seeing this answers my question.
Okay. So. Do you know that the test, that's going to be a lot easier because I'm a human being.
Right.
And if you do a sample space, I'll know what the sample space is. Because this is a piece of software, they can be pernickety. I mean, if you do the 5 trials at a question and you know when you see the answer that you were right, if you shoot me an email, I can just go in and give you the points that you would have been given.
Well, I appreciate you doing the homework or doing the tests the way that you do versus if we had to take them through the software. I think it would be frustrating.
It's pretty good when it's 3/4 or 0.712, right? And it's pretty good when there's 5 sentences and you have to pick the right one. Although sometimes I would argue about which one is the right one, but that can sometimes just be interpretation. But yeah, it can be a bit clunky in some questions. Are we good then? Is there any other questions while we're at this? Okay, that's a good sign. I'm being an optimist. It's a good sign, right? I'm going into student view here. Can you see Canvas 146, or will I have to go out and in again? Oh, you can see it. God, I'm on a roll today. Just there. Some of you get smaller screens, so I might. Okay. I don't know what I just called there, but it's probably not important. What you're looking at here is your test 2. There is an extra piece of information that I haven't put before, and it's called What You Need to Know for Test. It should say test 2, but I think I accidentally rubbed out the 2 when I was tidying up earlier today. Right, so let's click on that. And, oh, okay. There we go. Just took a few moments to load up, and I'll make it big. Right, so what I've put down here is everything basically in one place. So if on Sunday you can't quite remember something, or what are you allowed to and not allowed to do, you could have a look. Essentially, test 2 is going to be the usual 1 hour, 11 till 12, with the extra half hour to get it all up and running into Canvas. And it's going to have 4 questions. Although many of the questions are ABCers. So it covers all the things that we have done. Sampling methods, gathering useful data, examining relationships, intro to prob. Some of these questions do not require any working. You know, it's kind of, what is a double-blind experiment, you know? In which case you just write down in your own words what a double-blind experiment is. And now that I've said that, does anybody remember what a double-blind experiment would be? Want to share it with the rest of us?
The person who's in the experiment is unaware of, you know, like if you're taking the placebo or not placebo, they're unaware, and the person administering the placebo or not placebo is unaware. So right. Doctor patient, so, I guess, if you will.
Yeah, that's pretty much it. Now, sometimes the question will just require you to write a sentence, something like David's. Now, you know, people say it different ways, but as long as I get the gist of it, you're good. And other times, I just give you the word and I give you 4 definitions, but only one of them is right. You know, that kind of way. But whatever way it happens, can you see there's not going to be an awful lot of number crunching working, right? And that's fine. Some questions don't have that, right? And hopefully that's not a big deal. And we talk about, in some questions, there can be more than one correct answer. Okay, so I might give you an example of a story and then ask you to tell me what are the bias things that are going on. And bias just means, you know, what's stopping you from getting good data, right? So I might say something like, you're interested in the whether you have stolen something in your life. And so you phone 200 people randomly and ask them, have they stolen anything in their life? Tell me some of the reasons why you're probably not going to get good data. I think one of them's reasonably obvious, but there are others. Can you think of a reason that someone might not get good data by just randomly phoning 100 people up and asking them, had they stolen something lately?
A lot of people are just going to hang up for that phone call.
I'm sure you said, I just couldn't catch it. Melissa, what did you say, please? Again?
A lot of people would just hang up with that phone call.
Okay, so that would be called non-responders then, wouldn't it? Yes.
Or like simply lie.
It'd be nice if you could throw in the jargon word as well. That would true, right? You might end up with half the people don't answer it. So that is definitely a correct answer. I would like that. But there are others as well. Any others?
People could lie.
Yeah, that's another classic one.
Mr. Robertson.
They tend to lie, don't they, for things like that? Yes.
What if my camera is still broken by then? I haven't been able to get it to work.
Oh, please. Do you have a phone?
Yes.
Use that.
Okay.
Link to me through Zoom and with your phone.
Okay.
I think that's the 2 most common ones, but some people are really quite interesting and their brains work in other ways. So if I read your reason and I think it's plausible, I would still give you it. There's one minor one, but I would accept it because I think it's true. And it's nothing to do with the question, it's to do with the people I asked. I asked 200 people by phone.
Selection bias.
Yes, I'm not going to be able to ask people who don't have phones. Now, in some situations, that's more important than others. But I mean, I didn't say I want the biggest or most important reason. I just asked, give me some reasons, right? And those would have been good ones. It is going to, yeah, it's going to be the thing I dislike most in some situations. What am I getting at? I don't like English essays being a B when I think it's an A. And some of you are going to give
into the
me
front
what you
instead
think
of the
is
back, and it worked.
okay. Not sure what that is, but right, Ashton. So you're going to have to just, I'm just a boss. If I don't like your answer, sorry, I'm not giving you the points. And that's cruel, but I'm pretty flexible. But if you say something that I think is really a minor reason, I'm not doing it. But the ones we just mentioned, those last three are good. I don't see any problems with those three. I'm trying to think of a minor reason. Yeah. It depends if you phone them on the weekend or the weekdays, whether you'll get good data. Would you agree? Asking people whether they stole things, the day of the week you phone them is probably not going to be a major influence on the data, right? That would be a bad reason for why you think the data
I have
is
a
bad.
question. So would you rather us give like non-response bias because of this, or will you give us like the point even if we don't say non-response bias, or do we have to label it and give a reason, or can we just give a reason?
At this point in time, I would prefer you to do the non-response bias, but I would still give you the points if you didn't. It's just good
I understand that.
math. Yeah. But no, I wouldn't say, oh, she never used the correct jargon word for that situation. I wouldn't do it in that one. But you can imagine what I might do in a different question, where I gave you the same story and I gave you, this is a good example of non-response bias, and you know, and a few other ones, but the other three were rubbish, right? They had nothing to do with the story, but one of them was called non-response. So that would be the way I would test that piece of knowledge, by just giving you a story where that term would be the best way to describe what the problem was.
Sounds good.
And in a multiple choice question, there should only be one answer, and the other three should be just wrong. So hopefully that won't be an issue. So far, so good. Right. But things will come to you as we go through it. Here is the Zoom link. If we look at the rules, you are not allowed to communicate with any person live or dead. And that includes virtually. So you're not allowed to do Ouija boards and contact an old dead statistician. You're not allowed to do emails to your friend. Instant messenger. You pick it. I don't care. It's wrong, right? You're not allowed to. So basically, it's what's in your brain plus what you've written down as notes. So if you do good notes, maybe, for instance, go back to that question, you would might write down non-response bias and give a little description of what it is, so that if you got a question that had that in it, you could have a quick look and say, oh, that's the word I should probably put in my sentence as well, just to make it look better, right? Totally cool with notes, right? Totally okay with using your calculator. Any questions that involves numbers, which will probably be the probability questions, great, they're probably the ones you're going to do most numbers. Well, you put down what the numbers are, not just what the answer is. So it was 17 out of 415, and then you got nothing, 0.1234 or whatever, you know, after that. Just in case you hit the wrong button in the calculator, at least I can give you most of the points. You really do need to know what you're doing here. If you just say, oh, well, I don't really need to learn anything, I'll just write down lots of good notes, And whenever I come across a question, I'll find the bit of the notes that does that, and I'll read it, figure out how to do it, and just write the question down there. You'll run out of time. You just won't have enough time to do your questions if you do that. It's good to have notes, but only, you know, as an adaptation. Right, and the rest of this stuff we know about, I hope. Try to get out of this. And how to use Adobe Scan, you do not need to. Some of you have got a printer that turns your notes into a PDF. Some of you have other software that does the job, but Adobe Scan if you don't. And here's a video. Let me show you very quickly. If you click on this fella, I hope, start assignment. You've already done your working, right? It's a PDF. What I would do, you're doing it on your phone. What I typically do if I have this to send to students, I do it on my phone because it's quicker than typing it in Word. I email it to myself. I then go back to my computer. I download, you know, the file onto my desktop. And then when I do click, choose file, find my desktop, click on the guy, hit open, hit submit. Simple as that. And it's done. If you forgot, this happened to a student and it caused a little bit, it wasn't a big deal, but it caused a little bit of a problem. If you suddenly realize that you've missed a page, like you did 3 pages of homework, but I forgot the last page. It will upload, but it'll overwrite the first 3 pages. So what you have to make sure is that you send the whole blinking thing at one go. So resend the first 3 and the 4th one is at the same time. What else? Turn up for Zoom, get your video going, ask questions if you're stuck, hang about till it's uploaded. When I tell you it's good to go on Canvas, you are finished. Hopefully you'll get it all done well within the time. If this time slot doesn't work for you, because you know you're going to have another class right after it and you don't want to be pushed, we can arrange a different time slot for you and factor that in. For instance, extra time, you might want to start at a different time because of that. I'm about done. I'm really just wondering what I've not told you that you might want to know. Is there anything you'd like to know?
Hello?
Hello, Ethan. I think it's Ethan. Any questions? Okay, well, I'm going to hang about because you might have a question to ask, you know, just one-to-one. Say hi and bye-bye. Remember to say hi, that's how you get attendance. And then bye-bye.
Thank you. See you Monday.
Yeah. See you Monday, Sharon.
See you Monday.
See you Monday. Akila, West, you got West. I'm assuming you're going to say you need some different time because you need extended time or something.
No, I don't have a tournament next week, but
Yay.
I just had a couple questions.
Okay, questions are good. I like them. What you got?
The first one was way back to like the very first, I don't even know what to call it, assignment that's due on the 2nd.
They're all homework assignments, yes. So are we talking about week 3 and 4? Because week 1 and 2 are gone now as far as grading goes.
Yeah.
Okay. Do you know what section that homework was in? It started with chapter 5, sampling introduction. So which one was it in?
It was like the last 2 questions on sampling introduction.
Okay, I got you. I'm loading them up as we speak then. And the last 2 are questions 13 and 14. Okay. Right. Is this thing called the conservative margin of error? Is that the one that you're looking at? Is that the one that is trouble?
Is
right?
Is that just finding how many people are in that percentage?
No.
Or is that later on?
Well, that's probably later on.
Okay.
I'm doing a quick calculation here to show you. Okay. Oh, you're meant to see it, so I'll show you. The conservative margin of error is, you get it by a formula. Right? So I'll just call it M for short, right? The conservative margin of error is 1 over the square root of n, and then you write it as typically as a percentage. Now, n is the sample size. So in your question, I'm looking at, because you may have a different number than me, I'm looking at a sample that had 528 adults in it. So it's that guy. Now, since you want to make it into a percentage, you then have to do that as well. So take that guy, turn him into a percentage, and the answer to 2 decimal places is that. So question A was asking for the conservative margin of error. And with my numbers, it's 4.35%. But you might have a different, probably will have a different number, but that's the way you'll do it. And then you are told to compute an average number. How is it phrased? Compute an approximate 95% confidence interval for the percentage of all adults who would answer yes. And they told you that 70% of the people said yes, or sorry, they said 71% of the people said yes. And so the interval that they're talking about is you add and subtract the margin of error. So the number in the middle, if you imagine it, is there. You add 4.35% and you get this number. And you take it away on this side and you get that number. And these are the numbers they want you to get in question B. So clear that out. 71 take away 4.35. Oops, try that again. 71 take away 4.35. And the answer you get is 66.65%. And if you add it, you get 71.35%. And your answer will look like this. And that's what they wanted you to do. Now, what a 95% confidence interval is saying is that we're 95% sure that if you asked everybody, not just a sample, but the entire population, that the right answer would be somewhere in this range, at about 95% of the time.
Okay.